We're going to look at changing a quadratic from vertex form to standard form. So let's start with the warm-up. This is a review problem of what we looked at before. It's in factored form. Can you find the zeros of this quadratic? So we looked at this yesterday and earlier in the unit. To find the zeros, we're looking for when this equals 0. And using zero product property, it doesn't matter what each factor is. We can split it up. 3x minus 2 equals 0. So if this whole thing is 0, again, it doesn't matter what the other factor is. 0 times anything is 0. Or we can change this one to x plus 1 equals 0 and solve this and figure out what makes this 0, because again, if this factor is 0, it doesn't matter what this one is. So let's solve. For the first one, we'll add 2 to each side. We have 3x equals 2. So if we divide by 3, x is 2/3. And if we plug that in, x is 2/3 right here, it makes this factor 0, making the whole thing 0. For the other 0, we can subtract 1 from each side. We have x equals -1. And again, at -1, this is a 0 because if this is 0, the whole thing is 0. So if we were to sketch the function just by looking at the zeros, 1 0 would be at -1, and 1 would be at 2/3, so 2/3 in here somewhere. And it would be a parabola that looks something like this. Okay, more review. Can you write this quadratic in standard form? So standard or general form means no parentheses, multiply it out. You can FOIL or use a box. I prefer to use the box to multiply it out. So you have 3x minus 2, x plus 1, and 3x times x is 3x squared. We have minus 2x, and we have 3x and a minus 2. And then we write it in standard form with our highest power first, 3x squared. Combine like terms, 3x minus 2x is x, and then you have minus 2. So here's the quadratic in standard form. I can make an equation. All right. So yesterday we looked at we looked at standard form and we looked at factored form. But today we're going to look at vertex form and standard form. Back in chapter 4, first semester, we looked at the parent function y equals x squared. Sketch a graph of this. This will be your parent function for today. What shape is this graph? All right, let me actually move this down a little bit. All right, so let's sketch this. Let's plug in when x is -2, -2 squared is 4, so y is 4. When x is -1, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So if we sketch this function, we have -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. And then here's what our parent function looks like. That's not really good. All right, so there's our parent function, y equals x squared. The vertex, where it changes direction, is 0, 0. The line of symmetry right here was x equals 0. We can talk about domain. What are all possible x values? And we can say that all possible x values are all real numbers, which means we can plug anything in for x and we can square it. The range, however, will be anything 0 or greater. So if you notice there's no y values down here, there's a 0 for the y value and anything above that. So y is greater than or equal to 0 is the range. So we did an activity back in first semester that looked like this. You have the parent function without the dots, and you have the shifted equation. Can you write the equation of the shifted function using what we knew about up, down, left, and right? So for this one, this is left, 1, 2, and up 2. So the equation is y equals, and if it's left 2, that was the x plus the 2 in parentheses, and then up 2 was on the outside. The vertex, this point right here, is -2, 2. All right, let's look at this shifted function again. Here's the parent function. This shifts to the right 1, 2, 3, 4, and down 2. So y equals right 4, down 2. The vertex is this point right here, would be -4, -2. How do we find the vertex of a quadratic in these equations? Well, it's the opposite of what's in the parentheses, and then the y value, so the x value is the opposite of what's in the parentheses, and the y value is the number on the outside. So let's use that rule and find the vertex of each of these. So we don't have to write what h and k is, that's fine. Let's look at this function. The vertex would be the opposite of what's in the inside. This is 3 to the right, but down 1. This one is 2 to the right, up and down 0. This one is 0 left and right. There's nothing in the parentheses. Down 2. This one is left 5, but down 4. Okay, so again, it's what's the opposite of what's in the parentheses, but then up or down is the same. That's it on the outside. And then let's take a look at these ones right here. This vertex right here would be -2, 4. What does the -3 do to the graph? Well, it makes it upside down, and the 3 makes the slope really steep. So we could graph that and see what it looked like. Let's try that. Let's add a new graph page. So we have our -3, and we have our x plus 2 squared. And we have our plus 4. So again, you can see it shifts 2 left, up 4, and it's skinnier because of that steeper slope, and it's upside down because of the negative. This one shifts 3 to the left and up 1. How do we know if the vertex is the absolute minimum or maximum? Well, you think about the shape of the graph. Look at this number in front right here. If it's positive, and again, we call that our A, I call it the A value. If A is greater than 1, greater than or equal to 1, I should say, it's going to be positive. Well, even 0, we should say 0, because if it's positive. So 0, then it's a U shape up. If that A value, that number in front of the x is less than or equal to 0, it's going to be upside down. So this would be a min, and this would be a max. So it deals with your positive and negatives. All right, let's graph this quadratic in vertex form. So this one right here, it shifts. The vertex is -3, -1, and it's U-shaped up right here. So let's go -3, -1, U-shaped up. So we can sketch the function of the graph. It looks something like this. Okay. Oh, my workspace quit on me. Let's start again. Okay, let's take a look at the next one. So this one's going to be skinnier. Again, I feel like you can get the table. So again, we've graphed this right here. We can get the table by hitting Control T. And it will pull up a table for us to get different values to graph. And these get pretty small pretty fast. Again, here's some different values that you could graph right here. But again, if you just sketch, if you're able to sketch the vertex right now, I'm okay with that. And we've looked at doing the zeros as well. Okay, so let's do this one. The vertex is 2, 4. 2, 4. And again, if we do want the points, we can look at the table here. So -2, 4, we got -3, 1, and -1, 1. -3, 1, and -1. Oh, I graphed this wrong, didn't I? Oh, because it's -2, 4. Silly. All right, so -2, 4. And then -3, 1, -2, 1, or -1, 1, and so on. So it's going to look something like this. Okay, so from the vertex, can you graph it? We know it's upside down. It's going to be skinnier. You can use your graphing calculator, hit Control T to find different values. Okay, so that's the first part, which is if I give you the equation in vertex form, can you find the vertex and sketch the graph? The second part is, all right, can you multiply this out? And then I think that's it, and then we'll review. All right, let's multiply this out. You have to use order of operations. Order of operations, PEMDAS, we start with parentheses. So the first step, you have to multiply out x plus 2 times x plus 2 first. You can use a rectangle, you can FOIL. I'll FOIL this one. So we have first plus the outer plus the inner plus the last. So we have x squared plus 4x plus 4. There's the first step. In order of operations, we have multiply and add next. You have to multiply if you're using correct order of operations. So this is next. We have -3x squared minus 12x minus 12. And then the last step, you would add the 4. So our final answer is -3x squared minus 12x minus 8. I'll put the y equals there. So again, use order of operations. Multiply, or we should say do the exponent first, and then multiply, and then add. Let's do the next one. Okay, so again, this one, first step, FOIL or use the box. I'll use the box this time. So you have x plus 5 times x plus 5. We have x squared 5x 25. X squared plus 10x plus 25. Now we multiply everything by 2. So spider liked everything. 2x squared plus 20x plus 50. And then the last step is we have that plus 1 at the end. 2x squared plus 20x plus 51. All right, so that is converting it from vertex form, where we can look at it and tell what the vertex is, to standard form, where we could use quadratic formula to find the zeros. And then one review, we did this early on. Can you write the equation for the graph below? All right, so take a look at this. The first step is to find the x-intercepts, -3 and 1. The second step is to write the factored form, x plus 3, x minus 1. And we need to figure out if there's a scale factor, it's either 1 or -1. This one has to be -1, it's upside down, but to test it, we plug in a point. We can plug in -1, 4 for x and y. So we have 4 equals a times -1 plus 3, -1 minus 1. We have 4 equals a times, this is 2 and this is -2. And this is a -4, so we can see that our a value is -1. So the equation will be this, except we'll have a -1 right here. So 3 parts to today's assignment. You might have some review problems like this equation one. You'll have to multiply this out and use order of operations to write the standard form. And you have to be able to tell what the vertex is of a graph.